Hmm. A and T, C and G. So, okay. Interesting. Okay. So we have to do like a temporary replace. So like A with 1. Replace B with 2. There's no B. T. C. 3. G with 4. Okay. And then we replace 1 with T. 2 with A. 3 with G. And 4 with C. And that's because if we were to just do a direct replace A to T, that would get replaced back to A with this second rule, T to A. So we have to do an intermediary step. Let's test it out. One of the worst parts of Python, but we'll do it. Man, they had a lot of tests. Cool. Great. Let's do it. Calculate the numbers of the nth row. 1, 3, 5, 7. Oh, okay. So 1, 3, 7, 13, 21 times 2 plus 1 times 2 minus 1. No. Times 2 plus 1 times 2 plus 1 times 2 minus 1. So what's the pattern? 1, 3, 7, distance of 2, distance of 4, distance of 5, 6, 2, 4, 6, 8. So 1 plus 2 is 3, 3 plus 4 is 7. So you will have nth row, so the nth row is 2 plus 4 plus 6. And there's what's the sum of numbers 1 to n what is this shorthand? N times n plus 1 over 2. So n times n plus 1 is what we want. So we have 1 plus n times n plus 1 equals the offset. That was actually going to be like shorthand there. And then the length is just n. So, I mean, we could just be lazy. So this will be inclusive total equal plus equals the offset plus I times 2 return total. And I'm not explaining these as best as I could. So 3 should equal 1. Calculate the sum of the numbers in the nth row of the triangle, starting at index 1. 3 1 should equal 1. Oh, it's comparing my answer so I'm giving out 3. I starts at 0 though. The offset 1 times 1 plus 1 perhaps we need to do n minus 1. Oh. That gets us somewhere. Okay. So 1 needs to be 0. If it's 2, gotcha. 1 times 2 equals 3. 1 times 2 equals 2. And then that would equal 3. N equals n minus 1. 1 plus 0. Maybe. 0 should be 1. I understand. 1 plus 0. I in range of, oh, okay. So boom. Boom. When I have a better handle on this, I will start explaining these. When I, feel like it. All right. I have ranked up. Next kata. I hope everyone can see this. You are going to be given an array of integers. Your job is to take that array and find an index n with the sum of the integers to the left of n is equal to the sum of the integers to the right of n. If there is no index that would make this happen, return -1. Okay. Index 3, because the left side is this, and the sum of the right side is this. So you exclude the index. You exclude the index. So I think you can just sum array slice of like the first. So let me real quick. There's no need to not have something up. In order to test this out. So if I had an array, let's just take their first test. And I wanted to get the first 3, I believe that works. And if I wanted to get the last 3, that's how I would do it. Except in this case, it still includes that. So if I had an n, which is an index, and I set that to 3, then we would want to compare the sum of the array up until that index minus the difference, sum of the array at that index plus 1. And in this case, it's 0. So we have to do a loop. So for I in len of array minus 1, if, and this is going to be actually the solution here, for I in len of array minus 1, if the sum of the array up until I minus the sum of the array from I plus 1 is equal to 0, we want to return I. Otherwise, we will return -1. And we will test this. And the object int is not iterable. Right. We have to add the range. Hmm. 1, 2, 3, 4, 5, 6. So, what is wrong? Zero, 1, 2, 3, 4, 5. Zero, 1, 2, 3. 0, 1, 2, 3, 4, 5, 6. Alright. I'll take it. Apparently we didn't have to do the -1. Next. Write a function that takes a string of braces and determines if the order of the braces is valid. It return true if it's valid, false if it's not. Brackets and curly braces are valid. All input strings will be non-empty and will only consist of these three. This is true, that's false, and that's false. Gotcha. So we must so the way I'm gonna think about this, okay, let's just do this, this, this. So we find the first one. We should expect that the first one found is one of these. No, that's not right, because what about this case here? So I think what I need to do is remove anything that is like a pair, actually. Actually, this is interesting because, oh, I just thought of a really cool solution. Okay. Prev-len, what is it? Prev-len equals the length of the string. Okay. While the length of the string is not equal to the prev-len or the length of the string is equal to 0. Is not equal to 0. And Well, this is true and this is true. Well, so if one of them is false, it breaks. We are now going to set prev_len equal to the length of the string and do a fancy little replace with that with nothing. That replace this with nothing. Dot replace this with nothing. So my thought was initially, let's get rid of these guys so that we can unwrap product. And then I realized if it's correct, we should actually be able to remove things that are opened and then immediately closed. We should be able to remove those like until the string is empty, if it's correct. If it's not correct, you will end up with something like this or this that's just not closable. And if that's the case, then the length of the string would not change. So either way, we just need to, if it's true, the length of the string would be equal to 0. If it's false, we'll have something left. And I'm hoping this doesn't loop for an infinite amount of time. False should be true. So, sorry, that was really loud. Yes. Define it here. Check that it's not equal immediately after. Next, given two arrays A and B, write a function compare or compare same. I don't even know what they mean. Write a function compare that checks whether the two arrays have the same elements with the same multiplicities. Same here means that the elements in B are the elements in A squared, regardless of order. Well, first of all, if the length of array 1 is not equal to the length of array 2, we will return false, just right off the bat. For I in range of array 1, so for each item in the first array, if array 1 I, if the ith index, if the ith number in the array multiplied by itself, multiplied by itself, not in array 2, return false. Otherwise, return true. not be. Oh, what they do. What they do. Oh, you have to check the other direction. Yikes. I mean, I guess the length doesn't matter. Not learning rate. LR. So we need to check that the square root exists. So it needs to be 1-to-1 direction. I don't know this one off the top of my head. Import math. Cool. I know how to square root. What? Are you serious? Okay. If array 1 is equal to oh god, none, and or array 2 is equal to none. I think is none is the proper way of doing this. Shit. Okay. They clearly have some duplication. So they're duplicating the numbers for sure. So I need to remove the ones that we check. How do I get first index of value of array in Python? I don't need a numpy function. Yeah, I'll just do it from scratch. So we need to find we need to remove I. No, we just need to remove stuff from array 2. So for j, then if array 2j is equal to if array 2j is equal to the square, we can continue. And we will remove that item. How do you slice? Remove element from array. Really? In place. And then we can check if the length of array 2 is 0. Right. Again? Break inner? Cool, it breaks the inner. Great. Next. What does this mean? What is this? Interesting. Oh, I've already done this. Why would it bring up something I've already done? Some numbers have funny properties. Okay. Why would you multiply it by 1? 8 plus 81. Why multiply it by 1? Oh, is it a multiple of that? Yeah. Shouldn't be too quick to judge. Given a positive integer and written as A, B, C, D. We want to find, we want to see if this holds. Wait, hold on. What? 3, 4, 5, 6, 7. So, and it's taken at the successive powers of p is equal to k times n. If this is not the case. Oh, but oh. So there's got to be a rule for declaring that the starting power is too high. Oh, good. We're given P. We're given the starting number. We don't need... Fantastic. Fantastic. All right. Positive integers. So, we will do this. Int array. And I believe the clever way of doing this is as such. Now, there should be a split function. Python split. Oh, sorry, that was loud. And then list comprehension, man. And this should work. Let's just copy this. dig that power. Oh yeah. What? So this doesn't work as I anticipated it. Wait a minute. Why is n equal to something at all? That's very interesting. Splits on strings. I want it to split. Can I just do an empty string to split on everything? Oh, I'm an idiot. Strings are just arrays in general. That's how they're defined. Okay. Now we know we have an int array for I in range of, now we can do for n in int array, just get the number. We will do a sum with sum s, which starts at 0, and then s plus equals n to the p, and p plus equals 1. I know, mutation, don't kill me. And then we need to check if s divided by n is an integer. Wait a minute. Wait. Can I cheese Python real quick? So they give us this, which should be 1, which means this works. So 89 and 1 and 1. Excuse me. Should start at 1. 89 to the power of 1. Oh, jeez, man. Cool. And now what I'm interested in doing is cheesing Python. This is really bad. How many zeros are there? That's the question that's being asked. Sorry, how many items on the right side of the decimal place are there? And oh yeah. Is it equal to 1? I suppose not. Hold on. One and 0. not as characters. Oh, the length. Right. Is the length of the second item 1? Perfect. This is our solution. Oh, yeah. Okay. I don't need to run it here. I need to run it here. And do that. Nice. Beautiful. Given a string of words, you need to find the highest scoring word. Each letter of a word scores points according to its position in the alphabet. You need to return the string with the highest scoring word as a string. Aha. 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 All letters will be lowercase. And all inputs will be valid. Oh, okay. They're not gonna trick us with some bullshit. Now we have words. For each word, what do we want to do? Python letter to number in alphabet. So we want the ordinal minus 96. Def letter to number. C to integer, character to integer. Okay. A dot split. We're gonna try and one line this one. So now we have each letter. Yeah. We're gonna sum this. Maybe not one line. This will get us the scores. Again, no need to split on that one. We do want to split on this one. We want to find the maximum find index of max value in list. Is there a cool way? Wait. Oh. Yo, what up, Reed? I have a viewer. Yo, dude, I'm doing some programming. Shit. Did I miss it? Oh, no, you're still here. You just got here. So, and I'm gonna be talking to myself, Reed, mostly because I think this turns into a YouTube video, so people can watch it later, or I can at least download it and re-upload bits of it. So we want to find the doing this in one line is gonna be terrible. Yeah. Get the index. That's the index of the... You're making eggs and toast. Hell yeah. Alright, we're not doing this in one big... Right. Scores. We're gonna get the index of the max score. Scores.index max scores. Index. Now we gotta find that word. And in this case, it'll just be A for A. And then that index. We'll see if this works. Okay. Passed. Passed. Great. Where's all my notifications coming from? I have the... Sick. Sick. I'm texting back sick. There I am. Come and get me. Coding a massive schlong. Who's Logan? Yo, do me a favor. Just stay watching. You don't even have to watch it. Get me these viewers. Get everyone watching this shit. I don't care. I need 100,000 likes. And subscribe. Move the first letter of each word. Oh, I just lost one. I just lost a concurrent viewer. RIP. Oh, it's your horse. Send me a photo of Logan. I feel like I've seen your horse on your Facebook, but I can't remember. I think I see more of Kevin Sass's horse than anything. That motherfucker can't stop posting pictures of his horse. Move the first letter of each word to the end of it, and then add A to the end of the word. Leave punctuation marks untouched. So, how can I check if a character is a letter? if a string contains only letters. So is alpha. So this should, whoops. You should return true for something like this, even with caps. Is it dot is alpha? It is, okay. So the second I add something like that in it, it is all of a sudden false. They have a space here. I'm gonna just take a guess that they're gonna include that space. If they don't, I'll have to solve for it. So again, we're gonna split, take the whole string, turn it into an array of words, loop through each word. Actually, I'm gonna just really quick do this for word and words. If word, if the word is not alpha, we're going to continue. Actually, we're going to add it. We need to include it and then continue to the next one. Otherwise, we want the new word equals word. We want the new word to equal, starting from the first, skipping the first letter, plus all the way up to the last letter of the original word. And I believe, I don't even need to initialize it there, but I believe that works. So let's just check. We will set word equals to hello. And then set rest in peace. And then set the new word equal to this. Not quite. Is it -1 here? No. Oh, no. I just want the first, yeah. Overcomplicating it. Great. Plus equals A. And then we'll add it to the original array, which we will now return. We'll test it. Yep. Right. String join, or array join. No, Python join array as string. sick. So we want to do this dot join that. And we'll test it. We will attempt it. And we win. Okay, so I ranked up to 5, I guess. Let me go. So how does this work? So I guess I can just keep going. How do you do this? Let's crank up the difficulty here. Consider a sequence U, where U is defined as follows. First index is 1, and then for each item in U, y is equal to 2x. For each x in U, y is equal to 2x plus 1, and z is equal to 3x plus 1. Must be in U as well. There are no other numbers in U. 1 gives 3. And 4, then 3, gives 7, and 10, and 4, got it. So we need to memorize this, aka dynamic programming. So if you need the nth item, this is interesting. So really you just kind of want to go while the length of the working array, we'll call it working array, is equal to 1 while, the last one, working array, we want to slice on the last one. I just want the last one. So while the greatest number no. So I could naively, we're going for an index. I could naively say while the length of the working array is less than n. But here's the thing. 1 generates 3 and 4. 3 generates 7 and 10. 4 gives 9 and 13. So that's complete so far. Seven gives 15 and 22. You can see how many spaces there are. So you have to fill in all the gaps. Actually. Did I just lose the internet? No, I didn't. So you gotta fill in all these gaps. Gotcha. So we need to work out up until the nth one. Gotcha. So we will work from left to right. We can always go in order, keep appending, and know that when we get to the fourth one, there is no way to have missed one prior. So what we need to do is while, so we need to basically go through every index in n. I'm not explaining this very well, but that's okay. So for each item in n, what we need to do is we know that that index is at least going to exist. So what we're going to do is working array append 2 times this plus 1. So we'll append y. And now we're going to append z. And then what we're going to do is sort. Now, we should, at this point, have all the numbers we need. And this is an index, so we know we need to go one more. Invalid syntax, where? Yeah, we actually don't need this. Close. Is there a situation where I don't have the next one? Because now it's a length of 3. So with this, I should get out this array here in some form. 1, 3, 4, 7, 9, blah, 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 blah. So far so good. Doesn't tell me what comes after 27. Is the fact there's an even number in there? No duplicates. Wait. So I have to remove duplicates. I like this. Right. So I actually have to do this. Alright, so we'll do... Alright. That was pretty naive. Okay. We'll go back to this. We will set this to Y, as it wants us to do. We will set this to Z, as it wants us to do. If Y not in the working array, we will append it. So we may have to be more efficient than... So what do we know about... So the fourth one... I wonder... So we should be able to drop... Funny enough, we should be able to drop everything prior. Like, check it out. We should be able to drop everything in so starting at 1, we should be able to, okay, hold on. What am I trying to say? We should be able to remove every piece of information prior. What's up? What's up, my dude? Because we've already gone through it. And then that, okay, first of all, I need this set it equal there. So as we are churning through this, we can drop all the information prior so that at least the length of this stays oh, welcome back. At least the length of this stays shorter. We'll see if that's enough. Nope. 1 plus q equals 5/32. Q equals 1 minus 5/32. Wait, no, q equals 5/32 minus 1. That is the answer. Fucking algebra. I majored in pre-algebra. So now I'm like 1 over where we need to be. We'll see. Still timing out. So it's probably not this sort. We are adding, well, it's the fact that we're adding 2 new values every time. And this array gets long as fuck. Oh shit. It's Daddy Fat Chops. I'm a huge fan, bro. Your music videos are amazing. I watch every single one every time I wake up. Oh, how is my buddy Reed? How's your buddy Reed doing? Alright, let's look at this. Man, dude, this one fucking sucks. What do we know about this sequence here? Well, if you were to look at this 1, 3, 7, be 15. And then you have 1, 4, and then 3 times 4, 13. And then we're missing 9, so it's like every single one bifurcates. And the size of this array basically multiplies by 2 every single step. Not every single step, but... Well, okay. How do we know when we have enough information, I guess is the question. So if we want the 4th one, we need to at least get the 3. So the half one. If we want, what is this? The 6th one, we need to have, what generates the 6th one? Yeah, let's ask that question. What generates the 6th one? The 6th one is generated by 3 times 3 plus 1. Interesting. But in order to have done that, we needed to have gotten at least this up to halfway, basically. So really, we only need to do n divided by 2. In the case of 13, I believe it's still this one. So halfway is equal to n divided by 2 if n modulus 2 is equal to 0, else n minus 1 divided by 2. We're just going to call that an integer. I'm going to make that an integer. And technically we only have to go up to the halfway point to generate all the information. And then we can grab the greatest one. Is it the max in this case? I don't think it's the max. I think it's the halfway. Yeah. Let's just hold off on this. Okay, list index out of range. Alright, bring this into collab again. Yo, that did not work at all. So halfway should be equal to 5. 11 should also be equal to 5. For I in range of halfway. Oh, sure. 10 28? 10 is not 28. Oh, is this? N minus 1? Is 57. Oh. I might have been wrong. For a good measure, we can just do a plus. $57. 1, 3, 4, 7, 9, 8, 20. What? So I'm missing one. No, it's not halfway, of course. At the least, it's related to this. So minus 1 divided by 2. No, wait, that's literally what I had. 57 is generated by 57 minus 1 over 2 is 28. 28 is what index? Is the 12th index. I'm passing in 20. And I need 12. $13, really. It's also potentially divisible by 3. It's not. So at a minimum, oops, sorry. I need to get to the 12th, really the 13th number. So if I generate 20 numbers, $57 still doesn't show up. Oh yeah, that's right, plus 3. And then 30 should be 91. That shows up. On accident. if this works. Yeah, didn't think so. So 50. $195 minus 1, which is 97, which doesn't exist? Yeah, that's because it's the wrong number. 87, which is what? The 29th index. So what is this? Plus 4? So it's like slightly over halfway with this error rate that if you were to divide by 10 would be covered, plus int of n divided by 10. I'm afraid this still won't work though. Plus 1? Jeez. So arbitrary. Still not gonna work, I'm guessing. There's some recursive thing I'm missing. Oh, wait. There's a check we can do. So we can loop. So for each, okay, we have to reverse this. Something like this. We shouldn't be generating all these and storing all these numbers. For I up to some certain, or like okay, just So while counter is greater than 0, we can do this. So if current is equal to, so here's what I'm thinking. If current, there's no point of starting it at 2, -1 divided by 2 is, and if we can check, hold on. I know I did a whole number check earlier that was fun, but this needs to be efficient. So if this is an integer, so if you can subtract 1 and divide by 2, which every odd number you can, like this is step 1. Okay, this is step 1. If you can do this, if it's an integer, so the requirement is that it's in the list. So perhaps so if it's an integer, so we'll do x equals this, right? I'm sorry, y equals this, and z equals this, divided by 3. If y is an integer, and y is in, let's just call it w, spell it out, working. Then what we're gonna do is say working dot append y. Yeah. Oh, this is an or condition. Or this. We're going to append current. Yep. Current plus equals 1. Counter minus equals 1. I think this works. We don't even need the array after we're done. So $176, $175. Oh, yeah. Nice. So this is almost like a subtractive way. Is it fast enough, though? It's not going to be fast enough. Yeah, I got Windows 11. Yo, I just... So 3 and 4 are a pair. 7 and 9 are a pair. 10 and 13 are a pair. Plus 1, plus 2, plus 3, plus 4. Alright, we need a longer thing to work with. And I think this is accurate. I believe it grabs everything. Yeah. So, plus 1, plus 2, plus 3, plus 4, plus 1. Plus 2, plus 1. Zero numbers in between these two. One number in between these two for 3, yeah? Oh, I think this is how we have to do it. So 1 generates 3 and 4. So 1 goes to 3 and 4, and they have 0 numbers in between them. So 2 being the second number goes to, so 3 generates 7 and 10 with 1 number in between them. The third one generates, so this is 4 now. This generates 9 and 13 with 1 number in between them. And now we go on to the fourth number, which is 7. This generates, well, first of all, this is 2 and 3. This might be a better way of thinking about it. 2 generates 4 and 6, right? 7th is the 4, 10th is the 6th one. 3 generates 9, which is the 5th one. Yeah, this is we're on the right path here. The 5th one, and then 13th is the 7th one. 4 generates times 2, 8, 9. Oh, I'm sorry. Fourth one, 7 generates 15 and 22. Now, if I'm thinking about this correct, 15 should be the 8th one. And 22 should be the 12th one. Because I'm not doing this 0 indexed, yeah? 1, 2, 3, 4, 5, 6, 7, 8. Okay. 9, 10, 11. Gotcha. Then 5 generates 5, which is 1, 2, 3, 4, 5, 9 would generate 19 and 28. This should be 10 and 13. And then just to make sure I'm thinking about this correct, so first of all, 1, 2, 3, 4, well, I can just do this, 10, sorry, 9, Seven is 15. All right. That means 9 should be 19. The fifth one, 1, 2, 3, 4, 5. 9 times 2 is 18 plus 1 is 19. 1, 2, 3, 4, 5, 6, 7, 8, 9. Interesting. It's plus 1 instead of multiplied by 2. It's multiplied, it's the previous one. This should be then 12, yeah? So we're looking at 8 being 8 is going to be 19, and 11 should be 28. Have I generated enough? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 9 times 3, 27 plus 1 is 28. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 6 times 3, 18 plus 1. 6 times 2, 13. No, not 6. 4, 5, 6, 10, 21. And 25. 31. So 21 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm not smart enough for this one right now.